So far, you've learned 2 of the 3 methods to solve a system of equations. Today we're going to be working on the method that's called elimination. Now when I'm talking about eliminating something, I'm talking about crossing it out, like you would on a multiple choice test and eliminating it, or I'm talking about get rid of. In math, when we want to get rid of something or eliminate it, we need to make it 0. So we're going to work on making zeros today. Now the way that we make zeros is by finding opposite terms. An opposite term is the positive and negative version of a certain term. So if I asked you for the opposite of 3, the opposite term would be negative 3, because you have both the positive 3 and the negative 3. If I asked you for the opposite term of y, you would say negative y, because you already have a positive y. So what would be the opposite term for negative 7x? Absolutely, that would be 7x, because then I have both the negative version and the positive version of the term 7x. So when we're making the 0, when we're creating these opposite terms, that will help us solve systems by elimination. Here's a completely worked out example for you, and we're going to walk through the steps of it together. So we're given the following system: 10x minus 5y equal to 0, and negative 10x plus 2y equal to negative 14. The very first thing that I want to do when I'm doing these kind of elimination problems is label my equations number 1 and number 2. It's just because then we don't have to refer back to them as the top and bottom. We know that we're talking about the first equation and the second equation. The other thing is we need to always make sure these are written in standard form. So do you see how both of these equations are in alphabetical order? X's, then Y's, then numbers. X's, then Y's, then numbers. That's great. When you have it set up, both of them in standard form, it's a big hint that we may want you to eliminate one of the variables. Here's what we're looking for. We're looking for, between the first equation and the second equation, one of the variables to be opposite terms. Do you see how the 10x and the negative 10x between the first and the second equation are opposite terms? One of them is the positive and one of them is the negative version. That's the indicator that we can eliminate these terms. So what we're going to do is we're going to straight up add the 2 equations with an old-fashioned addition problem. Like literally, we're going to draw a big old plus sign as if we're adding this the old-fashioned way. When we add this the old-fashioned way, we'd add straight down the columns. 0 plus negative 14 is negative 14. Negative 5y plus negative 2y is negative 7y. And 10x minus 10x eliminates or crosses out because those are opposite terms. They make 0. So already I'm almost to the point where I can find what the value of one of the variables is. All I have to do is divide by negative 7 on both sides for this particular equation, and I would get that y is equal to 2. I'm already halfway there. The second or the last step is just as simple as it was when I was using substitution. I'm going to take that first equation and I'm going to substitute the value that I just got into one of the original equations and solve like normal. So look what we did. We've taken the first equation and we've plugged in 2 for y. At that point, all I have to do is solve like normal. Negative 5 times 2 is negative 10. So my equation would read 10x minus 10 equal to 0. I would take the negative 10 over to the other side. It crosses the line, so it changes the sign. 0 plus 10 is 10. And then I would divide by 10 on both sides so that x is equal to 1. And now that I have, again, both the x and y term, I want to put them into the the coordinate point as x comma y. This is my final solution to this system. I can always throw this system into Desmos, solve it for y, and check and make sure that 1, 2 is the point where these 2 lines intersect, because that is the graphical solution to a system of equations. Let's walk through the steps one more time. We make sure we're in standard form and that we have an opposite term. Then we straight up add the equations together, just like an old-fashioned addition problem. 0 plus negative 14, negative 5y minus 2y. We do all of this addition. leaves us with a single variable equation that all it takes is to divide. And we have one of our variables, halfway there. We plug that variable into one of the original equations. We chose the first one for the letter that we found. We found y, so we're going to plug it into y. Then we just solve like normal so that we can find out what x is equal to. And once we have x and y, we have our coordinate pair that represents the solution to the system. That's it. Now we have one more example before I'm going to let you try this on your own. So we're going to go to the inside of the notes here, and we're asked to solve the system by elimination. My first question to you, are these two equations both written in standard form? Yeah, both equation 1 and equation 2 are written in standard form. Second question, is there an opposite term here between the two equations? Yeah, hopefully you notice that the x's here are both positive 1x and negative 1x. That means that I can go ahead and straight up add these equations together like an old-fashioned addition problem, across the whole thing. And we're going to add 17 plus 8 is 25. 3y plus 2y is 5y. And x plus negative x eliminates. All we have to do now is continue to solve for y, or just divide by the coefficient, so that we can have the first part of my solution. Y equals 5 is the first part. I'm going to take that first equation, x plus 3y equals 17, and I'm going to substitute in this y, since I know its value now. So here I go, I'm substituting it in. X plus 3 times y equal to 17, but I'm going to substitute in the 5. I continue to solve like normal. 3 times 5 is 15. Then I'm going to take the 15 over to the other side. When it crosses the line, it changes the sign. So x would be equal to 17 minus 15, which is 2. So I now have the x and the y that create my coordinate pair. The x is 2 and the y is 5. And that is my solution to my system. Again, you can graph both of these lines and ensure that the point of intersection between the two lines is at 2, 5. Now, elimination, most students find much easier than substitution, so this might be the one for you. I want you to give it a shot. I want you to solve the following system by elimination. Let's make sure we can actually do this one before I send you off. Between the first equation and the second equation, are they both written in standard form? Yeah, standard form is alphabetical order, x's and y's in number, x's and y in number. Great. Is there opposite terms? Yes, hopefully you notice that there are opposite terms in the negative 2y and the positive 2y. I want you guys to pause the video and give this a shot. See if when you solve the following system by elimination, following the steps we've been doing, if you can find the coordinate point that represented the solution to this system. Go ahead and pause the video now. So here's my work. We went ahead and we added the two equations together so that we could eliminate the y's. 10 plus negative 22 is negative 12, and 2x plus negative 4x is negative 2x. Just divide by negative 2 on both sides to get that the x value is equal to 6, and that's what I'm going to substitute into one of the other equations to continue to solve for y. We plug in the x, so we have 2 times 6 minus 2y equal to 10. And then all I have to do is continue to finish solving for y like normal. Move the 12 to the other side, crosses the line, changes the sign. Then we would divide by the coefficient of y to find out that the y variable is equal to 1. This means that I have the coordinate of 6, 1 as my solution to this system. Because again, we always write our solutions as x, y. If we were unsure that this was the correct solution, as always, you can graph this system in Desmos and ensure that the point of intersection of the two lines is at 6, 1. We've now learned all three forms that we are going to use to solve systems of equations. You've learned how to solve them by graphing, finding the point of intersection, how to do substitution, what we did last class, and now by elimination. You're going to be allowed to pick which version that you like best and solve equations that way. We're going to practice all three ways, but eventually, yes, you do get to make a choice on what you like best. See y'all in class.